Hello, everyone. Welcome to this video on fine-tuning the Mistral-7B Instruct model to respond to YouTube comments using the QLoRA method. In this video, we'll walk through a Jupyter notebook step-by-step and explain each part of the process in detail. Whether you're a beginner or an experienced practitioner, this video will help you understand how to adapt a powerful language model for a specific task. First, we need to install several libraries that are essential for our task. We will be using AutoGPT-Q, Optimum, and Bits and Bytes. These libraries provide tools for working with large language models efficiently. Pip install AutoGPT-Q. Pip install Optimum. Pip install Bits and Bytes. To run this notebook first, we have to create the virtual environment and select the virtual environment for the Jupyter notebook. So create the virtual environment using this command. Python 3 m-vendmive. Now, let's activate the virtual environment using this command. source-bin/activate. Next, run the cell and select the virtual environment for the notebook. Additionally, to resolve an issue with the optimizer, we need to uninstall the existing version of Torch and install a specific version. Pip uninstall Torch. Why? Pip install Torch == 2.1. Next, we import necessary modules from the Transformers library. We will use AutoModel for causal LM and AutoTokenizer for loading our model and tokenizer. The pipeline function will help us evaluate our model later. From Transformers, import AutoModel for causal LM, AutoTokenizer, pipeline. From PEFT, import prepare_model_for_bit_training, LoRa config, get_PEFT_model. From datasets, import load_dataset. Import transformers. Next, we load our model and tokenizer. We're using the Mistral-7B Instruct v0.2 GPTQ model. Here's how we do it. From transformers, import AutoModel for causal LM, AutoTokenizer. Model_name equals Mistral-7B Instruct v0.2 GPTQ. Model equals AutoModel for causal LM, from_pretrained, model_name. Device_map equals auto. Trust_remote_code equals false. Revision equals main. Tokenizer equals AutoTokenizer, from_pretrained, model_name, use_fast equals true. We've now loaded our model and tokenizer. Let's set the model to evaluation mode to disable dropout modules. Model.eval. To test our base model, we craft a simple prompt and see how it responds. Let's start with a comment. Comment equals great content, thank you. Prompt equals f-inst comment/inst. Inputs equals tokenizer, prompt, return_tensors equals point. Outputs equals model, generate. Input_IDs equals inputs, input_IDs. To CUDA, max_new_tokens equals 140. Print, tokenizer.batch_decode, outputs, 0. Now, let's make the prompt more sophisticated by adding specific instructions for comment GPT. Instructions_string equals f comment GPT, functioning as a virtual data science consultant on YouTube, communicates in clear, accessible language, escalating to technical depth upon request. \. It reacts to feedback aptly and ends responses with its signature, ShawGPT. \. ShawGPT will tailor the length of its responses to match the viewer's comment, providing concise acknowledgments to brief expressions of gratitude or feedback, thus keeping the interaction natural and engaging. Please respond to the following comment. Prompt_template equals lambda comment, f-inst, instructions_string a \n comment I \n/inst. Prompt equals prompt_template comment. Print, prompt. Inputs equals tokenizer, prompt, return_tensors equals point. Outputs equals model, generate. Input_IDs equals inputs, input_IDs. To CUDA, max_new_tokens equals 140. Print, tokenizer.batch_decode, outputs, 0. To fine-tune the model, we need to prepare it for training. Let's start by enabling training mode and gradient checkpointing. Model.train. Model.gradient_checkpointing_enable. Next, we prepare the model for K-bit training and configure LoRa settings. From PEFT import prepare_model_for_bit_training. LoRa config. Get_PEFT_model. Model equals prepare_model_for_bit_training. Model. Config equals LoRa config. Art equals 8. LoRa_alpha equals 32. Target_module sadface Q_proj. LoRa_dropout equals 0.05. Bias equals none. Task_type equals causal_lm. Model equals get_peft_model. Model config. Model.print_trainable_parameters. With the model ready, let's prepare our dataset. We load our dataset from the shawin/shopped YouTube comments repository and tokenize it. From datasets, import load_dataset. Import transformers. Data equals load_dataset. Shawin/shopped YouTube comments. Def tokenize_function examples. Text equals examples example. Tokenizer.truncation_side equals left. Tokenized_inputs equals tokenizer. Text. Return_tensors equals NP. Truncation equals true. Max_length equals 512. Return tokenized_inputs. Tokenized_data equals data map. Tokenize_function. Batched equals true. Tokenizer.pad_token equals tokenizer.eos_token. Data_collator equals transformers. Data collator for language modeling. Tokenizer. MLM equals false. Now, we'll fine-tune our model. Let's set up our training arguments and start the training process. LR equals 2 times 10 to the power of -4. Batch_size equals 4. Number_epochs equals 10. Training_args equals transformers. Training arguments. Output_dr equals shopped ft. Learning_rate equals LR. Per_device_train_batch_size equals batch_size. Per_device_eval_batch_size equals batch_size. Number_train_epochs equals number_epochs. Weight_decay equals 0.01. Logging_strategy equals epoch. Evaluation_strategy equals epoch. Save_strategy equals epoch. Load_best_model_at_end equals true. Gradient_accumulation_steps equals 4. Warmup_steps equals 2. FP16 equals true. Optim equals paged_adam_8-bit. Trainer equals transformers. Trainer. Model equals model. Train_dataset equals tokenized_data train. Eval_dataset equals tokenized_data test. Args equals training_args. Data_collator equals data_collator. Model.config. Use_cache equals false # silence the warnings. Please re-enable for inference. Trainer.train. Model.config. Use_cache equals true. Finally, we save our fine-tuned model locally. And there you have it. We've successfully fine-tuned the Mistral-7B instruct model to respond to YouTube comments. To test our fine-tuned model in comparison of the base model, we will create a new file. First, we need to set up our pre-trained model and tokenizer. We're using the bloke/Mistral-7B instruct v0.2 GPTQ model. I have already returned the code, so I will just copy it and paste it. Now copy the path of fine-tuned model path and paste it here. Now run the file. Here you can see the output of base model and fine-tuned model which we saved locally. The output of base model is very generic and not responding YouTube comment accordingly. On the other hand, you can see the output of find model response. It is providing the response to YouTube comment. So, in today's video we fine-tuned Mistral-7B instruct model using QLoRA to respond to YouTube comments, and then save the fine-tuned model locally and test the output of fine-tuned model in comparison of base model output. Thanks for watching, and hope you found this video helpful. See you in the next video.